In this video, I'm going to be talking about 4.7 inverse trig functions. Basically, we can take our trig functions that we all know, hopefully, by this point, maybe. Say like we take sine of x, and we were to graph it, we would have the angles on the x-axis, so that we would have like pi over 2, and negative pi over 2, and all sorts of weird stuff. And just looking at our parent graph, we have, that's kind of our parent function. Right, it goes that way, and then the other direction it comes back this way, and it keeps going forever. So we know, hopefully, remember that trig inverse functions have to pass the horizontal line test. Well, if I try to do a horizontal line test throughout all of this, say I run a horizontal line through there, well, that hits it at a ton of points. So I know that if I just use my regular trig function and I do the inverse of that, it won't work. But if I can cut my function from where it starts repeating, say I cut it right there and I just kind of ignore all this other stuff, right? Then I won't have this part to contend with. And if I cut it from this on, I won't have to worry about this stuff. So that the only part of my graph that I'm actually looking at is that part right there. Okay, so that I can run a horizontal line through that entire part of that graph and make an inverse function with it. So basically, kind of the inverse function, if we switch our x and y, which is what an inverse does, it switches the x and y. If we go from pi over 2 to negative pi over 2, and sine goes 1 to 1, negative 1, I would start up here and down there, so I'd have this picture kind of like that. You guys aren't expected to graph these or anything, but I want you to know where these things come from. So for sine, for inverse sine, I can only have the angles between negative pi over 2 and pi over 2. Same sort of deal applies to cosine and tangent, but I'm just going to give you guys those intervals which we use. Here are the intervals that we'll be finding angles of. You guys are going to see something like sine inverse of 1/2, and you're going to have to tell me that theta is pi over 6, or whatever it may be. Okay, notice sine is only from negative pi over 2 to pi over 2. Those are the only places that we can have angles. So kind of looking at our coordinates, if sine is only from pi over 2 to negative pi over 2, then it's only in that region right there. It's only in quadrants 1 and 4, and the angles have to be between negative pi over 2 and pi over 2. Okay, so there's sine. Say we're looking at, oh, I just wanted a different color. It's not going to happen, apparently. Well, bananas. Woo! Purple bananas. All right, well, I'm just going to alternate my colors then. Actually, I can do this. You know what? I can do crayon. Yeah. Okay, so for cosine, crayon. For cosine, it can only be from 0 pi to pi. So that's only going to be in quadrants 1 and 4. Wow. Red rainbow. Yum. Okay, and then let's see. Let's get creative. All right. Whoa. Hey. Work, smartboard. Yeah, creative. Yeah. All right. So for tangent now, we only have quadrants 1 and 4 again. So kind of sine. Creative pen. Tangent. Bing. Looks like a target. That's cool. All right. So this is kind of the short way that I remembered it. It looks a little bit better when it's different colors and stuff rather than different materials. But these are the only places that you can have these angles. Okay, I'm going to go ahead and look at some examples, and you guys, I'm sure, will catch along with this. All right, say I give you cosine inverse of 0. Don't forget, this in the inside, this is the function value. What I'm going to be finding is the actual angle where that is true. So I think about my triangles. I have no triangle such that the adjacent side is 0 over the hypotenuse of whatever it may be. So since that is true, I'm going to go immediately to my points. By what we just said, cosine has to be between 0 and pi, so cosine has to be somewhere in this region. Since cosine has to be somewhere in that region, cosine stands for x, So I'm looking for when x is 0. Well, x is 0 straight up and down, that angle right there, that theta, is pi over 2. So that is my answer. It's just pi over 2. Okay, skis, here we go. Mr. Pike left the room, so we're going to see what we can do with the inverse sine. Looks like a sine is opposite over hypotenuse de los triángulos. Oh no, what happened? Right, pen. There we go. Pi over 6, pi over 3, 1 square root 3, 2. So, if it is positive, then hopefully we'll be in the first quadrant, no? Yeah, don't answer me. You can't anyways. It's a funny laugh. It's a funny. I'm laughing because it's so funny. Okay, so if we have opposite over hypotenuse, then the only angle that will give me an opposite to square root 3 is my pi over 3 angle. Pi sounds delicious. So using the pi over 3 as my reference angle, and I know I'm in the first quadrant, then there's my angle. So we have pi over 3. Oh, there he is. Sorry, guys, I had to chase a banana running down the street. It's a running banana. What am I supposed to do? Okay, look at this one. Cosine inverse of negative square root 2 over 2. And notice, it is cosine. So since it is cosine, cosine's only between 0 and pi. So I'm going to have to be in somewhere in these two quadrants. Cosine is positive in the first quadrant, so I know I'm not going to be there. So I must be in the second quadrant. Muy importante. Because whatever my reference angle is only that angle right there. So I'm going to have to figure out what the rest of the angle is so that that is my actual angle. Well, cosine inverse square root 2 over 2, I use the negative to figure out which quadrant I'm in. So now thinking about my triangles, my pi over 4, 1, 1, root 2, such that my adjacent side is square root 2 over 2. It looks like they already rationalized it. So really this is negative 1 over root 2. So I'm going to use that. So that pi over 4 is my reference angle. So there is my reference angle of pi over 4. So to get up to 1, I'm pi over 4 short of a whole. So I must have 3 pi over 4 as my angle. So I'm 1/4 less than pi. All right, I got 2 more examples for you guys. This one's a little bit crazy. This is just like composition of functions. When we had to work from the inside out, same sort of deal. You want to work from the inside out. So you're going to deal with this sine inverse of 3/5 first. Well, this is looking for an angle. I'm going to have some sort of angle as my answer. I don't know what that angle is, but something that I can do to help me is draw a triangle and choose an angle. Because I know sine is opposite over hypotenuse, so I can say from this angle, the opposite must be 3, the hypotenuse must be 5, and then by Pythagorean theorem, the other side must be 4. So there's my triangle. And I know my angle. I don't know what degree it is necessarily, but I do know it stands for theta, so I'm going to use that angle right there. So really all this is asking for is secant of theta. Secant is related to cosine. Cosine is adjacent over hypotenuse, so secant is hypotenuse over adjacent. So from your angle, the hypotenuse is 5, the adjacent is 4. So we have hypotenuse over adjacent. There we go, by force. That's what it's looking for. Meow, last one. So what I'm going to do is, again, composition of functions. Don't forget, inside out. So I'm going to find out what sine of... Oh, Mr. Pike messed up. Do-do-do-do. It happens. I'm going to say sine of 5 pi over 6. And it's going to be a different answer. Good. So what I'm going to do, because this is going to be looking for a value. Right, I'm given the angle, so I'm going to look for a value. So if I have 5 pi over 6 is in the second quadrant, and I have AS, so it's going to be positive. Then I'm going to look at pi over 6 on my triangle, 1 root 3, 2. Sine is opposite over hypotenuse, so this is really 1/2. All of this is just 1/2. So I can say sine inverse of 1/2, and then I want to find sine inverse of 1/2. I know sine inverse only exists in the first and fourth quadrants. Since it is positive, it must be in the first quadrant. And then to have 1/2, I must use my pi/6 angle, so that opposite over hypotenuse is 1/2. So really, this whole thing is just equal to pi/6. And there she is. Hopefully you guys enjoyed this video. I hope it was helpful, and thank you guys as always for watching. You're an awesome audience. You don't even say anything or distract me or anything. Wonderful!